Now in section 4 of chapter 10, we're going to take a little primer, so to speak, on logarithmic functions and see how logarithmic functions relate to exponential functions. As we see in topic 1 here of our objectives. And we'll use properties of logarithms to evaluate logarithms. And we're going to graph logarithms on the same set of axes to see how the curve, the graph of them, differ. Now, I like something a little more simple than this. Well, this is pretty straightforward. So if in your notes, you're going to write this out here. Now we have a base such as, let's say, 3. And then on that base we have an exponent. Such as 2. And that's going to equal an answer. So, 3 to the second power, our base to the second power, that's our exponent, 2, is 9. Now, this is the exponential notation here. Now, we can convert that to a logarithmic notation. Well, log just means exponent, and we add that to the word here. Log of a particular base and over here we put the answer So far we have log. Our base we said was 3. Our answer we said was 9. And this is going to equal the exponent, which we said was 2. So converting it from its exponential form to its logarithmic form. Remember, log is just an exponent. A log equals this exponent. So it's just set up a little differently here. So, again, I want you to have this in your notes. And let's see, for all positive values of x and all positive values of b, except b, that is, your base cannot equal 1. The expression b, our base to the y power, equals x is the answer. Okay, so that's sort of this one. And then we can express the log of base b, which is 3. The answer is 9. And the exponent, of course, would be our value here. So this is read, the log base b of x, that's our answer. That is, the exponent of this relationship is what y equals. I like it this way a little bit, and have that in your notes, so we'll use that as we move on here. Remember, a logarithm is an exponent. And another note, you cannot take the logarithm of a negative number. Keep that in mind too. In fact, you should write these down. Pause it. Now here, they want you to convert this to a logarithmic expression. So what's our base here? 5. So the log base 5, there's our answer, and there's our exponent. So pretty straightforward. Now again, take good notes. This is what you'll use as your models here. All right, once again. Log, our base is 3, our answer is 81, and our exponent is 4. All right, now this one looks a little interesting here. Let's just check it out. So log, our base is 6, our answer is 1, and our exponent is 0. Now remember, anything to the 0 power is 1. This is exponential notation. This is logarithmic notation. Now, when we start to use variables, it works the same. Log, our base is 4, our answer is 16. And they're saying the exponent is a. Well, we can actually figure out what a is equal to here by saying, what if our base is 4, what exponent brings us to the answer 16? Well, a here we're going to see equals 2. But again, they just want us to convert it to its logarithmic form. Okay, now it's in logarithmic form. We're asked to convert it to its exponential form. And this is just drill. So what's our base here? Our base is 3. Our exponent is 2. And 3 to the second is 9, our answer. Now, here, our base is 2, our exponent is 4, and our answer is 16. Our base is 2, our exponent is 4, our answer is 16. I'll do this one for you. Our base is e, our exponent is 0, and our answer is 1. Now, keep in mind that anything to the 0 power is 1. So in this one, our base is 10, our exponent is 2, our answer is 100. So sort of easy once you practice it, get the flow of how it's going here. Now we're asked to evaluate this. What would be the answer of this? So we start to convert it to its exponential form. Our base is 4. We don't know the exponent, but we know the answer is 4. So what is the exponent of 4 to what power gives us 4? And the answer is 1. So 4 to the first power is 4. And they're taking us a longer way to figure it out. All right, let's evaluate this. Now I see they're just saying converted to an equation first. That's okay. And that would be x then. So our base is 2. Our exponent is x. And our answer is 8. So 2 to what power is 8? Well, x to the third power. So x is 3. So this would be 2 to the third power equals 8. And there they go. All right, here's one. And again, some of these are so easy you probably can figure them out without writing them out, but you want to get a pattern. Our base is 25. 25 to what exponent equals 5? 5 is our answer. Now, in this case, it's going to be not a whole number, but a fraction. 5 to the 1/2 power. So it's the square root of 25 equals 5. And 25 to the 1/2 power is another way of showing the radical. And they're equaling it to x. That's a good way too. And it's x to the 1/2 power, which is the square root of 25. All right, now doing something like this, first, they're suggesting changing the equation to its exponential form. So let's do that. So our base is 16. We don't know the answer. The answer is x. But our exponent is to the 3/4 power. Now here, our knowledge of fractional exponents come into play. And what did we say this was? Well, we use our denominator as the index number. And we're raising this to the third power, and that's what equals x. So the fourth root of 16 is 2. 2 to the third power is 8. So where the x is, that would be an 8. So it's getting a little more challenging now. Now they're doing it a little different way. That's okay. The answer comes out the same. All right, now another tool that we have in our kit here of working logarithms is what we call the change of base formula. So if we have something like this, and you're just going to copy this down actually, if we have the log base b of x, we can shorten this in saying the log of x, this x here goes in the numerator, divided by the log of b. And our a we could put there, but when it's the same we don't have to. So what is the change of base formula? As long as b does not equal 1 and x is greater than 0, the change of base formula is, and we'll see an example of this, it's much better here, and I should erase this a little bit here. Didn't write that too well. So when you see something like this, this just goes as the log of x divided by the log of b. And you don't need to put the a's there, but it's okay if you do. All right, let's go on and see some examples. Oh, here they're asking us to graph the logarithmic using change of base formula. So when we convert this using the change of base formula, it's going to be the log of x over the log of 5. Let's take a look at it here. So the log of x, which is this, over the log of 5. Now, we're asked to use your calculator here to put this into a graphing calculator. And if you have a graphing calculator, this is what you can do. Now, when you put that in there and say graph it, it looks like so. And this kind of curve is very, very typical of logarithmic functions. Now, just as a little review here, while we have this nice graph here, if we had the ones that we've been working with here, and this would be our 1 here, this is the 1 there, our graphs that we've been doing in the previous section look like this, exponential. Logarithmic graphs look like this. Now they're not mentioning it here, but on this end, as it gets closer and closer to the y-axis, we get what is called a vertical asymptote, which is the y-axis. So again, there's lots of stuff they're not showing us here, and we'll, take it as needed, but this is just some background work here. Now, suppose you had, instead of a log, that you were going to use base e. Again, they're not telling us a lot of stuff. Base e is what we call a natural log. And there's a key on your calculator for the natural log. Now you might say these letters are organized differently. It looks like log natural. That's because it comes from the Latin. Logrimus naturalis is the way we put in natural logs. Now we can also use that for a change of base formula. Would it be the natural log of x over the natural log of 5? And if we put that in the calculator, it gives you the same results. So again, they're not telling us an awful lot about a lot of stuff going on here. And, I hate to put you out on this limb, but this is what they're showing us here. And if you put that into the graphing calculator, it looks the same. Okay, here are a few examples, and we are running about 20 minutes. So I'll pause here for a moment if you want to do any of these. And then these are the answers. And of course you'll have your practice and certify.